Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And we are here every Wednesday just doing these free math sessions to help you be more competent and confident in your math skills. And that confidence piece is a huge one because if you're not confident in what you're doing, oftentimes you forget the simple skills that you're working, that you have locked down, just because you're not confident in what you're doing. And so that confidence is key, but that competence, the understanding the actual math content is also key too. And so that's why we're here and we're doing what we're doing. Welcome to the month of December, such a holiday-filled month, regardless of what holiday you celebrate. I am going to wear a holiday shirt every Math Wednesday this month. So this one says, Merry and Bright. It's one of my favorites because it's just so cozy. But this is one of my many holiday shirts. It's actually, I'm not embarrassed at all by it, but some people might say I have one too many holiday shirts, but I am obsessed with a good holiday shirt. So I have a whole stack. So every Wednesday we'll wear a different holiday shirt. If you want to join in with me, let me know. You can join in and wear your holiday shirt too. Next Wednesday at my school, I think it's Ugly Sweater Day. So I will definitely be whipping out the ugly sweater for that day. But in the comment box, let me know where you're from, what test are you prepping for, and what holiday do you celebrate? Do you celebrate Christmas? Do you celebrate Hanukkah? Do you celebrate none of them? What holiday do you and your family celebrate? And, let's do a two-part question. And what is a favorite holiday tradition that you have? We have really enjoyed hosting. We've kind of created our own tradition. And so we've really enjoyed hosting. We started hosting Christmas about 6 or 7 years ago. And it has become this massive tradition where my whole family and my husband's whole family come over and we play games and we do a big crab boil. And it's just so special. And it's so special that we've kind of created it from the ground up. And so that's kind of our favorite holiday tradition. But where are you from? What test are you prepping for? The 2 more important questions. And what holidays do you celebrate in December? And what traditions do you have are the get to know you questions. It makes it feel a little less like a computer screen, a little bit more like we're all hanging out in my living room eating Christmas cookies together, or holiday cookies, or just cookies in general. And so, yeah. Without further ado, let's go ahead and get started. Leah, it is good to see you, my sister. I love, love, love seeing familiar faces. I am 100% a Christmas girl. I could watch all the Christmas movies. In fact, that'll be our question next week. What's your favorite Christmas movie? And I love that you take Christmas family pictures. That's so cute. I actually bought my whole family matching pajamas this year, and we're going to do the same thing. I don't know if we'll do it every year, but it's fun. All right, let's go ahead and solve the first problem together. Also, if you've been around for a while, you know that the iPad disconnects from the computer sometimes. In fact, almost every week it does that. And last week was the first week it did not disconnect. Can we talk about that? Like, can we talk about the fact that my iPad did not disconnect at all next week? That's a huge win right there in and of itself. All right, let's go ahead and do the first problem. Problem 1. A, B, C, D is a rectangle graphed in the XY plane. What could the coordinates of vertex B be? What could the coordinates? Oh, we did this one last year. Y'all, we're just going to skip this one. I vividly remember doing this problem last week. So if you want to see this problem solved, visit the video from last week on YouTube, but we already did this problem. So we're going to go right to problem 2. Hello, Andy. You're from Orlando, Florida? No way. Like, what part of Orlando? Because I literally live in Seminole County myself, like Orlando area, like drive through Orlando to get to the Mall of Millennia. If I'm like, in fact, that's where we're going on Saturday. Like, where do you live? That's awesome that you're from Orlando. I don't think I've ever had anybody in Wednesday night math night from legit Orlando, Florida. Hope, it's good to see you too. Goodness, we've got some familiar faces. You celebrate both Christmas and Hanukkah. Eating latkes is your favorite tradition. I love that. And hey, I love that you celebrate both. That's awesome. Hey, Edith, it's good to see you too. From Wisconsin, you love Christmas, and we tried to include Mexican food at Christmas. That's so cool. You're actually around the Mall of Millennia. That's funny. That's really funny. Yeah, we're up in like Seminole County area. Small world. I love it. So we could do math night together. All right, problem number 2. I had somebody specifically ask for function sets last week. I hope this is what you were asking for. If it's not, please, please, please comment and let me know what exactly you were looking for. But let's go ahead and look at this problem. This problem is definitely for my 6 through 12, 7 through 12, 6 through 9 math people. If you are not a person that's taking that, no worries. We will get to plenty of problems for everybody. So define the function f of x as follows. F of x equals 2x plus 3 if x is less than -2, x squared minus 1 if x is between -2 and 1, and 3x minus 4 if x is greater than 1. Find f of -2. So the interesting thing about this kind of problem is this is called a piecewise function, which just means that we have different pieces of a function being put together into one big function. And so I've got 3 different pieces of a function being put together into one big function. And if it's a function, let's remember, and this is for everybody, if it's a function, let's remember it has to pass the vertical line test. So I can't have something like this, even if it goes into infinity, because it doesn't pass the vertical line test, which means if I draw a vertical line anywhere on this graph, and if at any point it crosses the graph more than one time, it is not a function. The math way of saying that is that for every x, there can only be exactly one y value. So for this x value right here, there are 1, 2, 3 y values, which is why it's not a function. So that said, when we look at a piecewise function, we know that we can only have each piece on a certain interval, because if I have like a line and then I have a parabola, this together is not a function, because right here I would be crossing two different places. Now, this is an intersection of two different functions, but it's not one big function. However, if I did something like this, where I had a line and it stopped there, and then I had my parabola with an open dot here, then it would be a function, because for every x value, I only have one y value. And that's why a piecewise function is a function, because every chunk is different. So when I look at this, I don't need to graph it. What I notice is that I'm only doing this graph when x is less than -2. So for those of you who are visual, -2, 2x plus 3. I don't know where that, like, I could figure it out, but I'm not going to. All I'm going to do is say that it's a line and it's for x is less than 2. So it's going to be like a line that looks something like that. Is that exactly what it is? Probably not, but I'm just showing you visual. And then, and actually I want to do that in pink because I highlighted it in pink. Why did I put an open dot? Because it doesn't include -2. It doesn't include the -2. It's everything to the left of -2, because it's when x is less than -2. If that was a less than or equal to sign, it would be a filled in dot. And we're going to see that right here with x squared minus 1. So at x squared minus 1, I have something that looks like this. So, and again, these are not exact because I'm not graphing it with a table. I just want you to visually see. So with x squared minus 1, it's going to be a parabola that goes from -2 all the way to 1, and both of those have equals under it, which means I'm including that point, which is why you see a solid dot for both of those. And then we have, last but not least, we have 3x minus 4 for x is greater than 1. So 3x minus 4 for x is greater than 1 is going to look something like this. But you notice I changed my solid dot to an open dot, because if this was a solid dot, this wouldn't be a function because I could pass through 2 points there. But when it's an open dot, then it turns it into a function. Now, with all of that said, now understanding what a piecewise function actually is, they are asking us to find f of -2. How am I going to find f of -2? Well, I have to look at my piecewise function. I have to look at the range and figure out where in this range, which graph on this range includes the -2. In a piecewise function, there is only one possibility, and it's my green function. My green function is the only one that includes -2 because it has that equal sign. So I'm going to plug -2 into that piece only. It's a puzzle. So f of -2 equals x squared minus 1. Plug -2 in. -2 times -2 is +4 minus 1 equals +3. And that's my answer. I hope that's the type of question. There was someone on YouTube that made a comment yesterday about wanting to see this like a function set problem. And I'm hoping that's what you were looking for. If it's not, whoever's out there, let me know in the comment box if you want something different for everybody. Oh, goodness. Sorry. For everybody else, if there is something specific you want to see me go over next week, like a specific problem or a specific type of problem or a specific standard, let me know and I'll add it to my next week list here. You can also find me on social media, on Facebook, Amy Sink, and you can tag me in our Facebook group, and I'm happy to include anything in our upcoming sessions. All right, problem number 3. A trapezoid has an area of 240 feet squared. A new trapezoid is created by dilating the original by a factor of 3. What is the area of the new trapezoid? What is the area of the new trapezoid? All right, so this is a pretty straightforward problem if you understand scale factoring. And if you don't, I'm going to give you a really easy way to remember it. So a trapezoid, I'm just going to draw a friendly little trapezoid. This is a trapezoid. This is a trapezoid. And depending on what state you're in, that sounds kind of ridiculous, but every state kind of defines a trapezoid differently. A rectangle could be a trapezoid, but that's another conversation for another day. So the trapezoid has an area of 240 feet squared. A new trapezoid is created by dilating the original by a factor of 3. What is the new area? Now, the temptation would be to multiply 240 by 3. The temptation would be to do 240 times 3. However, that is not dilating the original by a factor of 3. What we need to consider is if we are dilating the original by a factor of 3, what we're doing is dilating all of the dimensions by a factor of 3. So if this was 3, this is now 9. And if this is 12, this is now 36. And if this is 8, this is now 24. And so with that, what we're doing is we're dilating the original linear measurements by a factor of 3. And so if we are dilating the linear measurements by a factor of 3, then in order to get the new area, we have to square 3 because area is squared. So 3 squared is 9. I'm going to multiply 240 by 9, and that will give me my answer. So 240 times 9 equals 2,160, which is D. Now, if they said a trapezoid has a volume of 240 feet squared, a new trapezoid is dilated by a factor of 3, what do you think we would do there? We would do 240, not times 3, not times 9. Volume is units cubed. So I have to take the scale factor and cube it. 3 times 3 is 9. 9 times 3 is 27. And I would multiply the 240 times 27. Does all of that make sense? Now, if that didn't make sense, or you're really, really confused about that, something that I do sometimes is I come up with fake numbers and then I solve it. So I would maybe say, okay, well, let me find the area of a trapezoid. I know the area of a trapezoid is base 1 plus base 2 divided by 2 times height. And so if I find the area of my original trapezoid that I completely made up, and I do base 1 plus base 2 divided by 2 times height, 15 divided by 2 times 8, is 60. And then I did the same thing with my new trapezoid that I actually dilated. So area equals 9 plus 36 divided by 2 times 24. $540. I can very easily see that that is not 60 times 3. What I can see is that if I do 540 divided by 60, it equals 9. So I can see my area scale factor is 9, which is what we figured out up here. But that is a test-taking strategy where you can mock up numbers and figure it out and then go from here to solving your actual problem, right? So if you're struggling to solve it, that you can kind of work backwards if you create your own problem. And I will often do that. If I'm stuck, I'll create my own very basic problem, and then I'll go from there. All right, let's go on to problem number 2. Problem number 3. Problem number 4. Goodness, I am struggling tonight. Problem number 4. I'm going to get a sip of water while we're reading this problem. Mr. Brown gave an algebra test. The scores of the students are shown below, except for one student who is absent. If Mr. Brown wants to have a class average of 82 on the exam, what does the absent student need to score on the test? Round to the nearest whole number. All right, so we have 92, 72, 76, 94, 83, 82, 84, 73, 71. So this is kind of useless information. It's what they do when they're building a word problem. They kind of put useless information in here sometimes. And we have some scores. We have some scores of students on an algebra test. But key information, Mr. Brown wants to have a class average of 82. Mr. Brown wants to have a class average of 82. What does the absent student need to score on the test? Round to the nearest whole number. So what I'm noticing is that I have how many, I thought we were going to get through without having to reconnect, but it happens to the best of us. So we're just going to reconnect the iPad and we will go from there. It's reconnecting right now. There we go. Okay, so I need to figure out how many test scores we have right now. So I have 92, 72, 76, 94, 83, 82, 84, 87, 73, 71. How do I find, let's start with this question. He wants to have a class average of 82. How do I find average? Average is the same thing as mean. And if you can't remember what it is, I have like a little mnemonic to remember: mean, median, and mode. So the mean is very mean because it makes us do a lot of work. The mean is very mean because it makes us do a lot of work. And so that is how I remember that you add everything up and then you divide it by 2. It's the most work. The median is like the median in a road. The median in a road is in the middle of the road. So the median of the data set is going to be the middle of the data set. And the mode is the thing that appears the most amount of times. And it sounds like that word. So I'm going to add all of these items up. But then I'm not going to divide by 9 because there's 1, 2, 3, 4, 5, 6, 7, 8, 9 items. I'm not going to divide by 9. But what I am going to do is add them all up, and I'll show you what I'm going to do in a minute. So I'm going to use my calculator. 92 plus 72 plus 76 plus 94 plus 83 plus 82 plus 84 plus 73 plus 71 equals 727. And then, you know what I'm going to do? I'm going to do it again. Because when you're adding this many items up together, there's a large room for like calculator error, like the fact that I typed it wrong. So I'm going to add them one more time. 92 plus 72 plus 76 plus 94 plus 83 plus 82 plus 84 plus 73 plus 71 equals 727. Now, that is what the 9 scores equal. But if I was finding the average and I want to know what the absent student needs to score, I need to have another student box here. So really, I have 727 plus box. And what is that? And then I have to divide that by 10, not 9, because the box is the 10th item, right? And what does that have to equal? What is the average that this teacher wants to end up with? The teacher wants to end with an 82. The teacher wants to end with an 82. Now I can do one of two things. I can solve this algebraically. So I can multiply both sides by 10, because to undo division, what do I have to do? Multiply both sides by 10. And then I can subtract 727 from both sides. And that equals 93. The other thing I can do if I'm lost is use my answer choices. So you and I have talked about, like, if you've joined me before, how our answer choices can be really helpful. So I know that I need to add all of these things up and then divide it by 10. And it needs to equal an 82. So by adding these things up, I know that I have 727 plus something divided by 10. And what I can do is I can now use my answer choices to figure out, does that equal 82? Does that equal 82? Does that equal 82? And if it doesn't, I can keep moving. Now, I never start with the first answer, ever. Because in this situation, if I start here and then I do B and then I do C and then I do D and then I do E, I'm wasting a lot of time. So I always start in the middle. In this case, C is the middle. But if it was just A, B, C, and D, I would either start with B or C. It doesn't matter. So we're going to start with C. 727 plus 65. 727 plus 65 equals 792 divided by 10, which is 79.2. That seems like it's way off. But then again, it doesn't, because it's a 79.2 and I only need an 82. So I'm not going to jump all the way to E. I'm going to go to letter D. So I know it's not C, but I know it needs to be, the average needs to be bigger. So I also know that A and B are not the correct answers because they're too small. If C was too small, then A and B are going to definitely be too small. So now I'm going to try D. 727 plus 81 divided by 10 equals 808. Divided by 10 equals 80.8. So that's too small. At that point, I could just circle E without even working it out because I did enough work to prove that it's definitely not anything else. So in the interest of time, if this was the method I was using, I would circle E and move on. Questions on that? All right, let's move on to problem 5. The average lifespan of a catfish is 60 years with a standard deviation of 3. Which of the following is the best interpretation regarding the previous statement? Which of the following is the best interpretation of regarding the previous statement? All right, so if we are looking at standard deviation, what we're looking at is a typical bell curve. So here's my graph, and I'm looking at this, where this is your mean. And then you have like your standard, first standard deviation, second standard deviation, third, first standard deviation, second standard deviation, third. And I always have to look this up. Okay, so I'm going to tell you what I'm doing. I looked it up so that I can give you accurate information. But even if I didn't remember it, I can actually still solve this problem without this information. Depending on what graphic you look at is going to change very slightly the information or the percentages that you get. But this section here and this section here are going to be the same percentage. These two are going to be the same. These two are going to be the same, and so on. So these two sections have 34.1% of the data. These have 13.6. Again, depending on the image or the statistical group that you look at, these numbers might change very slightly. Like this might be like a 12 or something. But it doesn't matter for the context of solving a problem like this. This comes straight from a solid GK review. And so if you need to know basics surrounding a standard deviation, this is what you need to know. There are very few people studying for a math exam that need to actually know how to find standard deviation. Very few people need to actually know the formula for finding standard deviation. So looking at this graph, the average, the mean lifespan of a catfish is 60 years, and the standard deviation is 3. So that means that I'm going to add 3 to each of these, and then I'm going to subtract 3 to get my ages for each of those standard deviations. So what this means when we look at this is that 34.1% of the data of the catfish are going to be between 60 and 63 years old. And 34.1% of the catfish are going to be between 57 and 60 years old. And then 13.6% of the catfish are going to be between 63 and 66 years old, and 54 and 57 years old. And then 2.3% of catfish are going to be between 66 and 69 and 51 and 54. And I'm guessing that that's like when they died. Like some catfish die at 51 and some catfish die at 69. And there's an outlier catfish that probably is still alive and he's like 80, right? So with that said, what can we conclude? That the median lifespan of a catfish is 65. Most catfish live to be older than 57. Most catfish live to be between 50 and 60 and 66. Or the longest living catfish lived to be 72 years old. So we cannot conclude anything about the data because we were not given exact data points. So I can't say that the oldest or the youngest or the median, I can't, or even the mode, I can't do any of that because we were not given cold hard data. So I can't tell you what the longest living catfish was. They didn't give us that information. They only gave us statistical data like this in a standard deviation format, but they didn't give us the outliers. So I can't assume how old the longest living catfish is or the youngest catfish or anything like that. I can't assume how many catfish are being discussed within this data. Like none of that was part of this. I also don't know what the median data or the median lifespan of a catfish is. I know that the mean is 60, but I don't know what the median or the longest living or anything like that is. What I do know and what I can conclude is groups of data. So what I do know is I can figure out where most of the catfish are. Most has to include 50.1% or more. So are most catfish older than 57? That would be all of these percentages. That would be 34.1 plus 34.1 plus 13.6 plus 2.3. Absolutely. That is going to be most. That is going to be well over 50% because 30 plus 30 is 60. And then I could add the 4, the 13.6, the 2, all of that. Most catfish are between 60 and 66. Well, that is just this section right here, and that would only be 34.1 plus 13.6, which is less than 50%. So the only viable answer is B. Questions about that? All right, let's move on to problem number 6. Find the vertical asymptotes of the function y equals x squared minus 7x plus 12 divided by x. Y equals x squared minus 7x plus 12 divided by x. So this problem and the next problem, we are looking at vertical and horizontal asymptotes. For this problem and the next problem, we are looking at vertical and horizontal asymptotes. Now, this is definitely for my high school people. We will move quickly through these two problems because it's really kind of straightforward, but there's not really a whole lot in here that's going to apply to my elementary folks. So how do we find vertical asymptotes? Well, you can literally set the denominator equal to 0 and solve. So x equals 0, solve, x equals 0. I mean, it's pretty straightforward. Now, to solve for vertical asymptotes, you're going to factor both the numerator and the denominator, And that way, if there was something that could like cancel out from the top and the bottom, those would create holes in your graph and it wouldn't be an asymptote. And then you would solve the bottom. But in this case, that's not going to happen. So after you factor and cross off any common factors, then you just set the denominator equal to 0 and solve. Easy peasy. Now, how do I find the horizontal asymptote? To find the horizontal asymptote, you have to compare the degree of the top and the bottom. So in this case, the degree of the top is 2, and the degree of the bottom is 1. If the degree on top is greater than the degree on bottom, then the horizontal asymptote is y equals 0. And then I'm just going to copy this. If the degree on the top is less than the degree on the bottom, then there is no horizontal asymptote. And if the degree on the top equals the degree on the bottom, then the horizontal asymptote is a ratio of the coefficients. So like if this was y equals x squared minus 7x plus 12 over x squared, then you would compare these, they would be equal. And so you would do a ratio of the top and the bottom. This is a 1 and this is a 1. So you would do 1 divided by 1 equals 1 is how you would find that asymptote. But in this case, that's not the case. The top is bigger than the bottom. If the degree on the top is bigger than the degree on the bottom, then y equals 0 is your answer. Questions? Alrighty, let's do another problem. A high school surveyed 1,000 students. The students were asked how many hours they spend watching TV a week and whether they watch cable or use a streaming service like Netflix, YouTube, Hulu, etc. The results are shown below. What percentage of the students watch TV via a streaming service? What percentage of students watch TV via a streaming service? So in this case, they surveyed 1,000 students, which means if I add all of these numbers up, it's going to equal 1,000. And I noticed that these are the students that watch cable, and these are the students that watch a streaming service. So if I'm trying to find what percentage, and this is for everybody, if I'm trying to figure out what percentage of something, I know that a percentage is a part of a whole. A percentage, a fraction, a decimal are all parts of wholes. So my percentage, if I have 100% is my whole, then I am going to do part over whole as a fraction, and that can give me a percentage. So my whole is going to be 1,000. There are 1,000 students. And then my part is going to be the students that watch via a streaming service, which is going to be all of these students. So I'm going to do 156 plus 264 plus 337, all divided by 1,000. So 156 plus 264 plus 337 is 757 divided by 1,000. And if I do that, I end up getting 0.757, and I can convert that decimal into a percentage by moving that decimal 2 places to the right, which is D. Excellent job, Leah. Now, let's solve another problem like it, just a different question. So all of this is the same, but now they're asking what percentage of the students watch TV for 2 to 3 hours. So in this problem, we were looking at a horizontal view of the data because we were looking at streaming services. But in this problem, we're looking at a vertical view because we're looking for how many students watch TV for 2 to 3 hours. We're looking at how many students watch TV for 2 to 3 hours. But we're going to approach it the same in the sense that we're still going to use over 1,000 because that's my whole. Now, are there other ways to approach this problem? Absolutely. So if you approach this problem in a different way but get the same answer, please continue to do that. That's absolutely acceptable. I'm going to do 369 divided by 1,000, which equals 0.369. Move that decimal, and I get C as my answer. Awesome. All right. Let's go ahead and talk about what we want to see in the upcoming weeks. We are going to be here together for 2 more weeks. So there is Math Night, December 11th. There is Math Night, December 18th. But then there will be no Math Night, December 25th. Or January 1st, okay? There is Math Night December 11th. There is Math Night December 18th, and then we're going to take a 2-week break for the holiday. Do you need to know the quadratic formula for the GK math test? Technically, it could be assessed. In everything that I've researched and done, I have not heard of a lot of people needing to use it on the GK, but it's definitely something that you need that could be assessed. Can I go over word problems using conversions? Yes, quadratic formula and word problems using conversions. Absolutely. Also, y'all, we have some super exciting news. We have some big changes coming to our Facebook community, and they're super exciting, and I want you to know about it. And so this is like the first time we're kind of rolling it out. We're building one big community for all of our teachers looking to pass their exams. So right now we have like a few different communities, and we're looking to build one big community, which is only going to benefit you because it's going to help you connect with other people who are also in the same boat as you trying to pass your certification exams. The link to join this Facebook group is going to be in the description of this video. So come back maybe tomorrow, and you will be able to, actually, it might be there right now. You will be able to join the group, but you're not going to want to miss our new group launch party on December 17th. So join me for Math Night on the 11th. Join me for our launch party in Facebook on December 17th, and then come for our Math Night on December 18th. It's going to be from 6 to 7, just like Math Night is. And there's also going to be an opportunity to win some prizes. So you're not going to want to miss that. And then we'll have 2 weeks of Math Night, and then we'll be on break for the holiday. So I hope to see you next week. I hope to see you at the launch party. And I hope that you have a great rest of your night. I'm going to turn it back over to Dr. A, and I will see you next week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.